Welcome to the AI GameDev, Europe's first research-driven competition to enhance game technology for AI scientists and startups. And as a gamer, I'm really excited about the output of this competition because we are looking at solutions to produce games easier and also to improve the games themselves. So, welcome to the final of the AI GameDev. There were many submissions, and there were two areas in which entries could be submitted. One was tech that supports the creation process, for example, creating music, sounds, animations, environments, or something like that. Or transforming real-world objects into digital models, for example, with better tracking, photogrammetry, or material estimation, or error reporting, testing, tools for better teamwork, and so on. The other area was enhancing interactivity. We all remember NPCs in old computer games. They often said the same sentences over and over again, did the same things. So why not use AI for dynamic decision-making or animations that adapt, or for better communication, or to create better simulations of particle fluids, crowds, and so on. Also, the world of AR or VR could use AI to get better. And we will see many approaches to this today. But first, let's have a look how AI and gaming are related.
We will see gaming everywhere in our lives, and at the same time AI. And these two things are going to become more and more coupled.
The reality is gaming and AI became the frontier to bridge between the real world and the computer world. So that's the biggest evolution that the industry had recently.
These intelligent systems will then feed back into games and make them smarter. And I think there'll be a virtuous cycle of AI making games better and then games making AI better.
Especially with the potential of new techniques like deep learning. So these type of AI, using this type of AI, you can infer or map data from one dimension to another better than a human would do.
Something that we are doing is we look at how should avatars look like in these virtual worlds, for instance. This is of course related to games. So how should avatars look in the games? Should they be like human-like? How far can you go? And those are things where we can apply techniques from artificial intelligence and machine learning.
So I see the future being much more of a merger of the real world, the virtual world, sometimes called the metaverse, and AI mediating between, or providing the interface between, the virtual and the physical.
AI has become such an important part of game development, which makes this competition so interesting. It's the first of its kind in Europe. Cyber Valley, Square Enix, and IT Farm created this competition to bring researchers and startups together and share their ideas. And what makes it even more interesting is what is in it for the winners. There are 3 awards. The first one is the Audience Award. It's powered by IT Farm, and the winner will receive an exclusive business mentorship by IT Farm covering topics such as fundraising advice, sales pitches, and business plan development. Then there's the Scientific Award, powered by Cyber Valley. It honors the most promising scientific performance, and its winners will get an exclusive Cyber Valley tour and meet top AI researchers. And finally, there's the main award, powered by Square Enix, for the most innovative AI solution. The finalist who wins the main award will get a trip to Tokyo. They will get to examine a potential cooperation with Square Enix on how their technology could be used in production. So those are great awards. A competition of this level, of course, needs a jury of experts to match. Let's get to know our AI Game Dev jury in our next video.
Remy Triancourt is General Manager and Director of Research at Square Enix, where he leads the Advanced Technology Division and the AI and Arts Alchemy. He and his team contributed to multiple famous Square Enix games, such as Final Fantasy or Marvel's Avengers. Isamu Hasegawa is Senior Manager and Technical Producer for Research and Development at Square Enix. He works on leading research projects that develop and provide Square Enix games with state-of-the-art technologies. Yuichiro Miyake is Lead AI Researcher at Square Enix's Advanced Technology Division and CTO of the AI and Arts Alchemy. His goal is to deliver new, unique forms of entertainment using 3D avatars or conversational AI. Johanna Perker is an assistant professor at the University of Technology in Graz, Austria. Her research focus includes games, AI, data analysis, and immersive environments that engage users to learn, train, and work together through motivating tasks. Michael Sedelmeier is professor at the University of Stuttgart, Germany, and head of the Augmented Reality and Virtual Reality Department. As an expert for human-computer interaction and data visualization, he contributes to the excellent research of Cyber Valley. Oliver Pasek is an advisor for film and media at the Ministry of Science, Research and Arts in Baden-Württemberg, Germany, where he takes care of the promotion of films and computer games. Shinya Kasuga is partner of IT Farm Corporation, a venture capital firm with a focus on seed and early stage or tech startups. He supports businesses and startups all over the world, particularly in gaming and entertainment, software, information services, or blockchain areas.
A great panel of experts, but you, dear viewers, are also part of the jury, as you will get to vote for the Audience Award. I'm sure our 7 finalist teams are quite excited already, so let's take a look at our green room where the teams are currently waiting. There they are. Those are our finalists. Maybe Team Evita, you're the first team today. Are you a little bit nervous?
Yes.
Yeah, I think there's nothing to be nervous about, because you all, the teams here, have great ideas, so it will work out perfectly. And maybe Team NeuroCD, I heard your project has something to do with the look of games. Is there a game that you would love to see your technology implemented in?
Yeah, sure. Final Fantasy would be a great match, I guess.
Okay, then you are at the right place, because Square Enix is behind Final Fantasy. So maybe this will happen today or in the future, and maybe winning this competition could be the first step to this goal. So we have 7 teams who made it to the finals of our AI Game Dev competition. We will introduce them all to you as the show progresses. You will get to know their ideas, and our jury will ask them questions on air. And all this can still influence who will win at the end. So let's kick it off with our first team, and this is Team Evita.
The team is essentially Nick and I. And so Nick is definitely more the one who has developed that technology throughout his PhD.
Okay, we are colleagues. We are sitting together in our lab. And Michael is doing more neural network stuff, cognition stuff. And my part is mainly the algorithm for generating the motion. The idea of my project is generating human motion and synthesizing face expressions for the Unreal Engine. So what this means is we developed an algorithm which can generate human motion in real time and can also generate face expressions. The main challenge is Unreal itself. Unreal is so huge, so it has so many classes, and to dig into the code of Unreal, because we want really a specific thing. We want to modify motion which is really in the core of Unreal. Yeah, so in the usual plugin development, Unreal provides already a good plugin development, but if you want something specific, then you have to dig deep into the core of Unreal. And this is really the main challenge.
So status now is definitely that, the proof of concept works. Now what we try to do is really somehow build the UI in Unreal so that people will really understand what they can do with the technology.
Realistic motions are so important if you look at a game, and so this is a cool project, I think. And now I would like to welcome Remy Driancourt. Remy, are you there? Great. Realistic motions are obviously pretty important for a game, but what are the most difficult part to animate?
Everything. We want to go away from baked, predefined animation because our worlds are getting more realistic, more dynamic. We have a lot of emergent gameplay going on. So having a robust way to generate animation on the fly is very important for us.
Okay, so it's a little bit about time, so you have to make it faster because there's so much to animate, if I understand it right. But I'm not the expert is the team. So now's the time for you to ask the team your questions.
So Nick and Michael, first, thank you for your presentation. It looks very promising. As you can guess, creation of animation is a super important part of our production work at Square Enix. So I'm going to ask a question that could require a long answer, so I apologize about that. But could you quickly walk us through what would be the typical workflow of a designer using Evita? For instance, would it need to record some extra data? How would you define input or the rules you want to see applied to a character, etc.? Thank you.
So basically, what our algorithm is doing is it generates human motion, and we are now working on face expressions. So it aims that are no special support for motion capture is needed. Yeah, the algorithm produces it by itself. So it's real-time capable. And what we also provide are control style changes and also do it in an interactive setting with the user. Yeah. So we provide this inside of Unreal right now, and we're providing this as a graphical programming inside of Unreal, where you can connect nodes and integrate it into the Unreal logic.
Okay. So if there is no need to create more data, my understanding is that you're going to provide companies like ourselves with a very rich latent space for animation.
Yes, right.
Thank you.
Yeah, I think this sounds great, and I think Remy is a little bit interested in it. So maybe one question I already asked at the beginning to another team. What is a game you would love to see your technology used in?
So for me, it's, for example, open world games, like Cyberpunk, and for Michael, I don't know.
I will actually also think of Cyberpunk or Red Dead Redemptions, where there is multiple stories and you can just openly going and interact with so many new characters, and it will just get new all the time.
Yeah. Okay. Yeah, maybe we will see this in the future. So thank you, Team Evita, and thank you, Remy. We continue with the next team, and this is Team Kinetics.
About 17 people right now, mostly engineers. So on my side, I lead the business and partnership role and the community growth of the business. Henry, my co-founder, is in charge of the AI part, and he works with 7 engineers in AI and machine learning. And Philippe, our VP engineering, is in charge of the platform and the 3D, and he has more than 25 years experience in game development and software development. The idea of Kinetics is to create a platform to allow all the creators and in-game creators to animate their own avatars leveraging AI. We first started with the prototype. It was in June 2020. Then we raised money with the Entrepreneur First and investors to grow the team. And we received also public funding, and we won deep tech prizes here in France. And since then, we signed big partnerships with other industries like media and also filmmaking to develop further our technology. Now we have a community of more than 4,000 users, creators that are using the platform, and we're very much focusing on the quality level of the outputs of the AI. It's also a challenge because we're developing a 3D animation tool directly on the cloud, which is new compared to all the software that are used today, like Blender, Maya. So this is an additional challenge, but it's going pretty well with the team.
3D animation for everybody. This sounds great, and as a gamer, I'm really excited about this. So, also a very cool project. And now I would like to welcome Shinya Kasuga from IT Farm. Hello, Shinya. The team wants to make 3D animations for everybody. Where do you see possibilities to use this technology besides gaming?
Actually, the opportunity is everywhere in the world, especially in the metaverse. Metaverse is not only about the virtual world, but actually it's about the intersection between the real world and the virtual world. So it's if you want to animate anything, in the virtual digital side, then that avatar animation, can be applied to all kinds of real world applications like digital twins, real world capturing, or kind of simulation, in the virtual world, So there's a huge opportunity in this technology.
Okay, big potential. So now's the time you can ask the team your questions.
Okay, so yeah, thank you for your great presentation, and I can see a lot of huge potentials as well as great advantages for your technologies. And my question is, what makes your product defendable against competitors now and in the future? And for future part, please especially describe what piece you have to fill in order to make your product widely scalable and defendable.
Thank you for your question. It's a super interesting one. So there are multiple players working on how to generate AI animated content. What we do is to create a product that is very simple and that automates the whole workflow. So basically, we integrate libraries of characters, libraries of animations. Not only the defensibility is on the quality of the technology, but also on the UI and the UX of the product and the integration with all the metaverse platforms. We're also launching NFTs within Kinetics so that people can own their content. So it will be a loop of people owning their content, leasing it to other people so they can co-create together. And we already have a community and we're growing it very fastly. So the lock-in will be on the tech and on the community. And one of the blockers today, of course, is the real-time capture. It's harder because there are challenges of quality, so it will be one of the blockers in the future as well.
Thank you very much.
Okay, here, big potential in this idea and also a great answer on the question. So maybe this would be the team who wins. We will see. And now it is time to take a closer look at one of the creators of this competition, and this is Cyber Valley. Let's see.
Cyber Valley is a consortium that includes the Max Planck Society, the University of Tübingen, the University of Stuttgart, and many of the major companies in this region and around Germany, as well as some international players. It involves startups, venture capitalists, and all of us are engaged in an effort to make Germany a hotspot, really, for artificial intelligence research, as well as commercialization in large companies, small to medium-sized companies, and importantly, in creating new startups that will become eventually world leaders in the space of AI. Already back in 2015, we saw a need for this The automobile industry was under pressure from many different directions. And we saw an opportunity to partner with the auto industry to really think about what the future is going to be and how it's going to be transformed by artificial intelligence.
There's all sorts of different research done in Cyber Valley, all around the topic, the main theme of artificial intelligence. So we are doing research on virtual augmented reality and data visualization, for instance. But there's also great stuff on machine learning, on motion capturing, on haptic feedback devices, and that sort of stuff.
The goal really is to teach computers to have human-like capabilities.
This also gives a responsibility for us as researchers, but also for decision makers such as politicians to make sure that these algorithms are fair and good algorithms in the end. Machine learning and artificial intelligence have really substantially changed the world already for the last decade. But I don't see that there's a stopping point now. It's the opposite. Many areas have shown that they can highly benefit from machine learning approaches, from artificial intelligence approaches.
And the growth will just continue. After 5 years of Cyber Valley, it's amazing what's happened. When we set out on this journey, we wanted to create an AI hotspot that would be recognized around the world. And we've effectively provided a template for how business, academia, and government can really work productively together and creatively together. I think we'll be done when everybody in the world knows the term Cyber Valley, when it's as famous as the term Silicon Valley. So we're not quite there yet, but we're on the right path.
So those are big goals, but I think they will make it. So now we have Michael Black with us, and he will answer some questions. Michael, we just heard you want Cyber Valley to be as well known as Silicon Valley. What is your vision to achieve that goal?
So what drives Silicon Valley success is not an organization. It is a culture. And it's a number of elements in an ecosystem. There's universities like Stanford and Berkeley, which are drivers of fundamental research and technology and also produce many of the talent that spurs the region. And then there's a long history of innovation, startups, and the combination of venture capital together with the software engineering talent. And there's also good weather there, by the way. So in terms of Europe and Germany, I think we've got the weather. It's pretty good here. We have wine growing and other good things that California has. And what we've built so far is the Stanford Berkeley-like engine. That is our new graduate school, the International Max Planck Research School in Intelligent Systems, with over 200 students, PhD students. It's one of the largest graduate programs in the world focused on artificial intelligence and intelligent systems. And we're building this culture of innovation and entrepreneurship. And that's what we are pushing now. The next phase of Cyber Valley is all about spinning off companies, fostering them, helping them grow, and making this the region in Germany and hopefully around Europe to start your next venture in AI, because the talent is here, the money is here, we've got the nice southern German climate, so everything is ripe for this.
Okay, so there are many points that speak for Cyber Valley. If I understand it right, it's important for you that you get those talents to come to Cyber Valley. What does the talent have to bring in if they want to get to Cyber Valley?
Well, look, there's all kinds of ways that people participate. If you look at Germany today, and you're looking for hiring software engineers, there is no better market than the Stuttgart-Tübingen region. The amount of talent here is immense. The quality of life is good, so it's easy to attract people to the region, and the infrastructure is good. So we have that. we felt we really needed to increase was the pool of really trained people in the area of AI. So in addition to the PhD program I mentioned with over 200 students, the University of Tübingen started a master's program, an AI master's program, to train practitioners to be proficient in the latest technology. And then, having great educational institutions like the University of Tübingen, the University of Stuttgart, this is a key, right? You have to drive things. So I think the talent is here, the infrastructure is here, and we just encourage people to come and join us.
Okay, you already mentioned AI, and it's such an important technology, but also AI is changing very fast. So what is the most interesting development in AI that you saw in 2021?
In 2021, well, very relevant to the topic we're talking about here is what's going to transform computer graphics. I mean, computer graphics today is very traditional. It goes back, decades. We have three-dimensional triangulated meshes. We put textures on them. We define material properties. We light them and put them in a scene and render them. Right. This is the classical paradigm. It produces results that are highly realistic if you've got artistic talent and lots of time. And where AI is transforming that today with deep learning, neural rendering is a hot topic. Neural radiance fields, also called NERF, is a super hot topic. And what these things are showing us is that we can work much, much faster than the traditional graphics paradigm to produce highly realistic animations and renderings using this, replacing the entire rendering pipeline, the classical one, with a neural network. And this will revolutionize every aspect of graphics and gaming. But it's a complicated switch because everything has to change. The entire pipeline that we've built everything on for games and special effects has to kind of be swapped out and replaced by new tools. And I think this is an amazing opportunity for whoever gets it right and figures out how to do this. And also figures out how artists can maintain their kind of creative control. How do we bring artists and neural networks together to create really exciting and novel content? So I think it's this merger of AI and graphics that's the hot thing this year.
Okay, so there are a lot of opportunities, and probably the teams here have those opportunities, and they try to use it, and I think they will use it. You already mentioned graphics is an important part and is getting better. Do you have some other examples where AI is used in gaming?
AI is used in gaming all the time. People talk about AIs in games. They're not very smart at the moment. What we would like to see is much more automation where intelligent agents exist in games and can interact realistically with people, reducing the workload on animators and increasing the realism of it. And as was mentioned, as we move to something like the metaverse, which is fundamentally a merger of the digital and the physical, these agents have to come out of the game and interact with a physical world that they've never seen before, that the animator hasn't seen before. It's unknown, right? So we have to create the 3D world, understand it, and then have agents that can interact with it. They can't be pre-programmed. They have to be truly intelligent. They have to sense the environment, understand how to interact with it, understand how to interact with people. And so I think that's where the big challenge is and the excitement is about, for me anyway, in AI going forward. But there are lots of other applications.
Okay, you already said artificial intelligence is in many games, but often it's not so smart.
Yeah,
I'm not sure if it's maybe a hard question, but is it possible to define when an AI is smart? What makes an artificial intelligence smart?
Yeah, it's a great question. It's as old as the field itself, and of course, people go back to the classical Turing test as a definition of intelligence. Now, what does the Turing test involve? It involves typing questions on a little piece of paper, slipping it under a door, having either a human or a computer answer these, type out an answer, and slip it back out under the door, and then you read it. Right. So that is a form of intelligence, but intelligence goes way beyond that. Brains have initially evolved not to type little things on a piece of paper, but to move the body. Movement is the reason we have a brain, and a complex brain. And so I don't think a truly intelligent agent that's like us is going to be very interesting without movement. Now you could debate that, but I think movement is key.
Okay.
And so we need an extension of this Turing test idea to include natural behaviors that are indistinguishable from a human. So if I take an avatar, a virtual agent, and put them in a virtual world that they've never seen before, and tell them to do something, they should be able to do anything in this virtual world, and it should be indistinguishable from a real human in a real version of that scene doing the same thing, right? And if I can't tell the difference between an artificial agent and a real human, then I would argue that we have some kind of basic intelligence.
Okay, motion is key if you want a smart AI. And I have an idea why you mentioned motion, because you are working on motion capture and we have the chance to talk about it later. So thank you for the moment. And for now, let's continue getting to know our finalist teams. And the next team is NeurCG.
As of myself, I am a PhD student in Perceiving Systems Department of Max Planck Institute for Intelligent Systems.
I'm a postdoctoral researcher here. I started about 6 months ago.
When we play some kind of computer game, there is a close-up of a person. This is not as expected, the quality. And we want to fix that using the recent developments of the AI technology, and thereby make it look more realistic.
How can we actually use all this knowledge and all these new technologies that are coming out in a project that can be commercialized, let's say?
If there is something new and it's not established, then it's very hard to trust on that and keep working for, like, let's say 8 months or a year, which is, let's say, 33% of the whole PhD budgeted time, only to maybe know that it's not going to work at all. So that was one of the very big challenge I started with, I think. So people did not believe that this could be done.
The key problem that we're solving is realism in gaming. We're trying to reduce the cost of generating very realistic faces by not having to go through this very costly pipeline of creating the 3D assets and having artists to touch it.
Also a very creative team. I loved how they used the door as a whiteboard, pretty cool. And now I would like to welcome Johanna Perker from our jury. Johanna, this team aims to make character faces more realistic. What do you think? Will there be a time where you can't distinguish between game and reality because it's getting so realistic?
I mean, if you think about also the metaverse, there's much potential for techniques like this. So I'm really excited about such approaches, and yeah, I think this will be super relevant.
Okay, so the team is on the right track. So now you have the potential to ask them your question. Here's the team.
Yes, thank you so much for your presentation. Very exciting. In your submission, you already described the potential for the approach for the games industry, but I would be interested, what would you see as the next steps to actually get it ready for industry applications? So I'm thinking about topics like performance or how to integrate it in existing tools or processes in the game development industry. Thank you.
Yeah, so the technology is essentially a conditional generative model. So we take the pre-game buffers, so essentially the pre-renderings as image form, put it through a neural network. It makes it more realistic, puts them back together in terms of the environment lighting and all of that, that the game engine does as post-processing. And after that, you essentially receive directly the high resolution fixed images of the faces. So obviously it's going to change to the whole scene and to the whole body and so on later on. This basically tries to target the entry barrier directly, that as a game developer or a game engineer, you don't have to switch out the whole process that you have had before. just give us images, we give you back better images, and you render them like you used to before.
Okay, so a lot of potential. What are the reactions you get to your project from the people?
I mean, Victoria, would you like to take it?
I think you can answer this better, but usually the idea itself, for sure, I think everyone knows that this is faces are a key thing in gaming. So the idea of having actually realistic faces of whatever, Messi or us or whatever, it's exciting. And in terms of the product, I think the original prototype delivered quite good results. So at least when it was presented in 3DV, it had a quite good feedback. But that's a part that I can speak more.
Okay. So thank you, Johanna, and thank you, Team NeuroCG. And we go on with the next team. We have so many teams in this competition. So the next team is Team Malaxar.
Being trained as an architect, I was shocked when I entered the profession at the limited role that new technology played in the design process. And so I started by trying to create an innovation, trying to create an AI that could think creatively. And so the idea behind our startup is that architecture design is a manual, inefficient, and inflexible process. And this is a problem when designing one house, but it's a huge problem when you design an entire city level or world. And that's exactly what happens in video game design. So our startup is creating an AI engine to generate architecture models for the video game industry. We built a team around really trying to look for the right creative people and the right problem-solving people to fill those positions. So our team is pretty diverse, from people like technical artists to more creative artists. So people like visual effects artists who are focused on the overall aesthetic, the user experience, and the way the cities are generated. There are a lot of challenges when you are trying to work on a very technical level and also on a very creative level. So in many ways, actually, what we are doing is pushing the AI to think beyond, in a sense, these kind of technical restraints. We can be a tool that all of this future development of the metaverse, where people are building digital worlds and new characters and having completely new experiences, we can be the foundation for that. We can be the most innovative, most creative tool.
Video. We will see it later when it's corrected. And I think for now we might move on. And here, the next part we're talking about is we heard the name Square Enix a lot today. And Square Enix is a company that sponsored this competition as one of 3 companies. And now I would say let's take a look at Square Enix and get a better understanding what this company does.
We are an international entertainment conglomerate. We are kind of a well-known video game company. So we are best known for game series such as Final Fantasy, Kingdom Hearts, Dragon Quest. We are also investing a lot into new technologies such as avatar creation or conversational AI. What we are creating, are basically pieces of software. So I'm not going to make artists happy, because a lot of artistry and design goes into these productions. Sound, 3D modeling, programming, storytelling. So this is where we might differ from purely technological companies. And from a technological point of view, so this is not just about the most realistic simulation. This is not just about the quality of the algorithm we can create. We need to consider culture, how humans or artists, designers are going to interface with the system, and how a new technology can integrate into an existing team's workflow. So what I mean by game AI, this is how you would simulate the behavior of non-playing characters or enemies in a game. So mostly things like perception, decision-making, navigation. How do you get an agent to move from point A to B in a virtual world? Things like squad AI, for example. So there is a very tight connection for most of these systems with designers and gameplay. On the other hand, there are some techniques like planning that we have been trying to integrate for the last few years, but machine learning and natural language processing are still very new to what we are doing. Any aspect of production could theoretically benefit from AI. Whether we are talking about the creation of a texture, sound, 3D asset, animation, AI can support artists. AI could help us perform tests as a human tester would do, or potentially, it's a new field of research, help us create game levels just like a designer would. And artists and designers could basically direct work together with an AI companion, providing them with variations and recommendations so they can work at a higher level of abstraction and focus on creativity. The most important part of production, and we need this human factor to control the fun. No machine can just invent the fun on its own. So it's more about offering AI as a support tool, an enabling tool, rather than replacing humans, which doesn't really make sense.
So Remy from Square Enix is with me right now, and Remy, you are working on improving the creation process of games with AI. What are the biggest challenges you see there?
Yes, before I jump into the questions of AI, talking broadly about the challenges we have at Square Enix, they are not fundamentally different from other companies in the gaming industry. I think a lot of these challenges we are facing have to do with flexible management of scale. What I mean is the computing power of gaming devices, whether we are talking about a console, a PC, a smartphone, or a server on the cloud, this computing power is evolving at a tremendous pace, following Moore's law, according to an exponential trend. And so does the expectation of our customers regarding the size, density, or the visual fidelity of our world. So companies like Square Enix are constantly trying to create larger worlds that we want to fill in with more assets, with more details, more unique characters and story, better simulation models, etc. So in order to do so, you would logically need bigger teams with more specialized staff, but there is obviously a limit on the size of the team you can hire or just manage efficiently. So we can't afford to have our team and our production cost grow exponentially the same way computing power does. So we need to be smart and constantly improve upon our processes in order to flexibly manage scale and scope and keep our production cost as much as possible under control. So that's the reason why there is, in the gaming industry, such a strong interest for proceduralism, simulation, or automation. And that, of course, brings us to the topic of AI. Obviously, proceduralism and automation don't necessarily require AI, but modern AI is so powerful and flexible, it can help us solve such complex issues in a smarter, more robust way.
So maybe you can give us an example where you're using AI right now in your company.
That could be kind of a long answer. The first issue I have is the word AI is not very well defined. It is certainly not limited to machine learning. It can encompass a wide range of techniques. And typically in the game industry, we would differentiate between two big categories of what you would call AI. So the first one, this is what we would call game AI, which purpose is essentially to create models of character behaviors that feel okay, feel interesting in a game, and whose research topics are usually related to autonomous agent architecture, path planning, decision making, and this is always very, very close to gameplay or animation. And secondly, the more academic discipline of artificial intelligence. So a lot of the candidates we have here today with us are from this field, and this is quite new to the gaming industry. This is not the traditional game AI. So in that field, I would place deep learning. And these techniques, this field is a lot concerned with fundamental mathematical problems like analysis and mapping of high-dimensional spaces, approximation and optimization of functions, data interpolation, extrapolation, etc.
Okay.
So it's very generic. And in our division, we conduct work on these two different aspects, game AI and artificial intelligence, and also how the two could combine to create new forms of game interaction.
So there are lots of use cases for artificial intelligence. So thank you, Remy, for your insights. And maybe one of the following teams will win the main award and visit your company in Japan. So let's take a look at team number 5.
We're at a group at the University of Tübingen, and we are 4 team members. So one is Yi Liao, and she's by now an assistant professor in China. The other one is Michael Niemeyer, who is currently also not here, but he's doing an internship at Google. And the last other team member is Andreas Geiger, who is my supervisor and who is a professor at the Tübingen University. Yeah, and me, I'm a PhD student in Andreas Geiger's group, and I'm in my 3rd year now. The main idea is that generative models are usually really good in the 2D domain. So by now, neural networks are really good in generating very photorealistic 2D images of faces or of animals or whatever. And we thought it would be very cool if we can not only generate images in 2D, but if we can make these images 3D controllable. But the important part is that in our project, we want to learn this only from raw 2D images. So we don't want to use any 3D training data because usually it's quite difficult to obtain this. One challenge was to familiarize with this very new, very recent 3D representation that was proposed. And then the main challenge was to integrate it or to extend it such that it actually allows the model to become generative. Yeah, and for generative models, there's actually there's two difficulties. So the first one is in general to train one of these models because they are very, let's say they are not that easy to tune, and it needs a lot of fine-tuning and adjusting. And the other part that was, of course, difficult is then not to have it just in 2D, but in 3D, and to make it really controllable.
From 2D to 3D, very important step. And now I would like to welcome Isamu Hasegawa. Isamu, what is the most interesting topic for you about this project?
This is very interesting also for me because gaming industry has many problems. For example, we need to create many assets, and the quality must be more improved one. So artists need more and more tasks. If this technology will be implemented in gaming industry, it helps the artists create those assets, and they also can do more creative tasks.
So it helps the creativity. That's great. So now you have the chance to ask the team your question.
Okay. At first, thank you very much for your submission and great presentation. I would say it is innovative enough and looks very interesting for me, but I'm afraid that it is not sufficient in terms of quality for HD, high-definition games, such as Final Fantasy franchise in our company. For example, I can see small artifacts on the car body and unnatural shadows. I would like to know how you can improve the quality more and more in order to implement this technology into those HD games. And also, I'd like to know the brief roadmap for the improvement if you have.
Yes, that's a very interesting and very relevant question. So since we published this project, we were lucky to get a lot of attention and feedback on this research area. And there already are follow-ups work where the visual quality of the images is greatly improved and where it's really starting to look very photorealistic. So one way that this can be done is by a slight change in architecture of the neural network that we train. And yeah, so the step that we took was basically like a first step to merge like this new representation and the computer graphics with this generative models. And so since then, there's already been a lot of improvement. And I think by now, like the latest works in this field can actually get you very close to high quality photorealism already.
Thank you very much. I'm really looking forward to seeing your latest work. Thank you.
Yeah, and thank you, Isamu, and thank you, Team Graph. And now we get to the last contestants, and let's take a look, before we do that, at IT Farm, and we prepared a little video for this too.
IT Farm is a venture capital based in Tokyo and investing in early-stage disruptive tech startups across the world, mostly outside Japan, actually. And we especially support international startups to develop business with Japan economy, such as market entry, partnership development, and fundraising. We are one of the founding members of Cyber Valley Investor Network to support European AI entrepreneurs. And phenomenal changes in the gaming technology area is that the technology started to largely intersect with other industries outside gaming. For example, electric vehicle, the cars in the auto industry is leveraging game engines. And some people may have thought, 10 years ago that gaming and AI is just like all about toys, how people play with, just kind of nice to have stuff. But the reality is gaming and AI became the frontier to bridge between the real world and the computer world. From investors' point of view, we want to see ambitious startups that starts from gaming area, but also scales even beyond the boundary of the industry. Great startups always address significant and compelling challenges. This is very important. If you are solving a serious issue, which many people are all suffering from, then they will be eager to pay money to you right now. Even if your product is still at an early stage, they will anyway pay. In contrast, no matter how advanced technology you have developed or how mature product you create, people will be slower to pay money if you are just providing a nice-to-have solution and will not solve their serious issues. So this is not about business technique or sales skill, but actually is about the purpose of the idea, how significant issue you are solving for the customer and for the world. That's the key for the great idea.
Hello, Shinya. You're an expert on tech startups, and maybe you have some tips for anyone who wants to start in the gaming industry.
Yeah, thank you. Yeah, that's a very great question. So there are literally millions of startups in the world. However, the startups that are invested by the venture capital or institutional investors, and to keep the growth is only a very few portion of them. And of course, there are hundreds of elements that the successful startup has to have. But if I would choose just one from them, then it would be the key would be that the startup targets a big market. And then, obviously the question is, what is the big market, for the startup? And if you are, from a large corporation, then, you may go to like, a public library or government statistics, market research report, and check, which part, has the, large number. For example, like, how many customers in the market, or, a big investment report, or, large IPO, event, etc. Then, would that, work, same for the startups? The answer is unfortunately no, because, from venture capital point of view, we don't call, those market a big market, but rather we just call it a crowded market. If everyone, a lot of players are already in that market. The point is that, the current big market it could be attractive for the incumbents. However, for the startups that innovates the world, they have to target the future big market. And what creates the future big market is, the answer is, that today's customer pain, creates the future market. So if, the customer or the users are strongly struggling, with something, and then, if you provide the solution to that, then, everyone would be happy to immediately pay money for that and, make it as a business. And so if you, solve a big challenge, big problem of the world, then, that makes, the future big market of, for the startup. So yeah, that would be one of the very important key for all the startups.
So you have to analyze your market and then plan what you want to do and where maybe you can join in, if I understand it right. So maybe another question which is important for startups, are there some big mistakes many startups make, and how can you avoid those mistakes?
There are thousands or even more, anti patterns or typical mistakes, that the many startups, may cause. However, again, if I would choose one, then the focus, the startup has to laser focus, on one specific, strong area of the market in the beginning. Entrepreneurs are always ambitious, and everyone say, "Oh, I will change the whole world, with this technology." Yeah, that's true. Yeah, your technology will have the potential, to change the whole world. However, you are still a small startup, so you can't, tackle the whole world at once. In order to, change the whole world, you first have to start from the very tiny portion of the world. Even if that is tiny, you have to start from the very important challenge of the world, and then starting from that small portion, laser focusing on some specific area or specific application, and then you can scale the market. You can get the customer, you can get the money, you can get the traction, you can get the partner, you can get the members, employees or engineers, and then you can gradually, step by step, scale your product into different areas. So, I see a lot of, startups, trying to, emphasize that, oh, I can provide, this kind of feature, this kind of feature, this kind of feature to cover, customer A, customer B, or industry C. But, the greatest part of the startups is that you can laser focus and penetrate this market.
Yeah, so you should dream big, but maybe not too big, because maybe you will lose your focus. So thank you, Shinyar. And now we are coming to our last teams. Next one is team number 6, and let's have a look at the Game AI Research Group.
Sure. So our team consists of 6 people. We have 3 academics or 3 researchers from Aalto University, which is close to Helsinki in Finland. So that's the academic side. And then we have the collaboration with the game studio Hovi Entertainment. It's really important in development. It's really important to guide design and make sure for game designers and developers that the design intentions are correctly in the game and that it's going to be appreciated. What's usually done is that human playtesters are being involved. The problem with human playtesting is that it's costly and time intense, and it's also really quite tedious work. I think in short, our model is capable of predicting player churn and pass rates in games without actually involving any human players.
Certainly, there were a lot of challenges. A lot of these are mostly practical, and these are shared by all projects in the same front. So AI-based game testing, it's mostly that the deep reinforcement learning agents are just super slow to train. So you need to kind of try and see what works.
Our idea is situated in this area of player modeling, especially player behavior modeling. So it's about predicting how players behave, what players experience by AI methods. And AI agents best case behavior can be a stronger predictor of human play than the agent's average behavior. And that's an insight you can use in many other research projects, not only in our predictive model. And that quite fascinates me.
Also, a very important idea. Nobody likes it if there's an error in a game. So here is Oliver Pasek from the jury. And Oliver, testing code is really important. How much time do you think is usually spent in testing a project?
Well, there should be a lot of time invested in, and I think a lot of projects failed, even with the big companies. I think of the start, for example, of Amazon own gaming projects, for example. So the phases for testing of involving the community must be very strong, and in even some popular cases, they haven't been. So yeah, there's a lot of time which should be invested in this.
Okay, so the team has a good idea for this. Now you have the chance to ask them your question.
Yes, of course. Human behavior is such a big thing, the prediction. And of course, it has a lot of potential, even or mainly for the serious game side. But in the context of monetarization, maybe when you monetize your project, it mainly consists of predicting the player engagement, and you also might want to sell it in a B2B environment. So how does this get in compliance with data protection regulations, so that a sustainable business model can emerge? Perhaps you can tell us something about the Angry Birds use case, how you handle their player data. That would be nice. And thanks for the great introduction also.
Hey, sure. So I can tell you briefly how this collaboration with Rovio Entertainment worked. It was basically us sending Shagaev Rohi, who was the PhD student driving force behind this project, to Rovio, who agreed to give us their data set of about roughly 100,000 players' data on playing their game, Angry Birds Dream Blast. The story was they gave her the data, they advised her on key insights on their player population and on player psychology. They kept all the code, the data, and intellectual property, but allowed us to publish the results, so it's now available to everyone to use. That's what I can say from our side. When it comes to using this data, you have to consider that we only use player data at one point in the development, and that's when we try to fine-tune a model to accurately predict the engagement and difficulty experienced by this specific player demographic. So the model can then be used on future levels that these players have not previously seen. So since this is only done once, it can be done in quite a secure, safe environment without exploiting this data any further. In a new project, in a new game, we would use new data from this new player demographic specific for this game. So we won't use player data between projects necessarily. We don't have to do that. And I think that gives us an extra layer of privacy.
Yeah, thanks very much.
Sure.
Okay, yeah, also thank you from me. And we had some audio difficulties. Maybe you can program something for Zoom that checks the audio too. So thank you to the team. Thank you to Oliver. And from automated playtesting algorithms, we go to motion capture with the introduction of our next team. And this is Team Savita.
So I'm responsible for developing the algorithm. Kushag is responsible for the backend to develop the infrastructure. Ashwani Arora, he is the management person. And then we have Ayush Saini. He is responsible for developing the app. The idea came to me that these days, the motion capture doesn't need any markers. Why don't we do the same thing on the smartphones? To give an example of a home workout assistant using our API, they will be able to judge the 3D pose of the person, then give much better and detailed feedback. So the feedback that I got from my pitch, that's what motivated me. We are in like 3 different countries. I'm here in Germany, Kushag in Netherlands, Ayush and Ashwani are in India. So it's quite a challenge for us, especially for the synchronization of the ideas, and how we handle it is fixing the meetings basically.
Okay, thank you to this team. Maybe the motion capture could help me on a smartphone, for example, with my workout. We will see. Now, Michael Sedelmeier is with us. Michael, is there a big difference when you're programming for a smartphone or for a computer?
Of course, there is a big difference. Smartphone, you definitely have less computational power. You need to be more careful about these things, and you need to work with the data that you're getting. The idea, I think, is really neat, of course, because before Michael Black already mentioned, motion is going to be key to AI. And so if you can bring these sort of algorithms like motion tracking to cell phones, to smartphones, you all of a sudden go into a game where you can democratize motion tracking and bring that to everybody out there, and that would be pretty cool. But it poses a lot of challenges because of the limited resources that you have.
Sure, challenges the team is facing, but much potential again. So now is the time you can ask the team your question.
So first of all, Nitin, thank you a lot for this lovely presentation and also for your submission. So you said that your approach obviously necessitates a lot of data that you need to plug in, and that you want to get this data by essentially giving the SDK for free to the developers, and then in turn get the data from them that you can use to train your models. So how will you deal with privacy and with ethical concerns? Sorry, this is just in time.
Yes, this is a very quick question, and privacy is a big concern for us. And I would say the way to deal with is not to send the data back to the server, which is the full video or where the person is recognizable. So what we plan to do is do some processing already on the phone, and then that process data is sent back to the server from which we can learn. One example is just the 2D key points. So this processing is already available on the smartphones, and we have algorithms which can learn from just the 2D key points. We don't need the full person. And I think this is a good solution, because the user will agree to log this data rather than the full images where the person is recognizable.
Okay, thank you very much.
Yes, privacy, very important topic at the moment. And yeah, thank you to the team, and thank you to Michael. And now I have to say sorry to Team Malaxar, because we had some technical problems, but we fixed it. And now we can jump to the last team, and this is Team Malaxar.
Being trained as an architect, I was shocked when I entered the profession at the limited role that new technology played in the design process. And so I started by trying to create an innovation, trying to create an AI that could think creatively. And so the idea behind our startup is that architecture design is a manual, inefficient, and inflexible process. And this is a problem when designing one house, but it's a huge problem when you design an entire city level or world. And that's exactly what happens in video game design. So our startup is creating an AI engine to generate architecture models for the video game industry. We built a team around really trying to look for the right creative people and the right problem-solving people to fill those positions. So our team is pretty diverse, from people like technical artists to more creative artists. So people like visual effects artists who are focused on the overall aesthetic, the user experience, and the way the cities are generated. There are a lot of challenges when you are trying to work on a very technical level and also on a very creative level. So in many ways, actually, what we are doing is pushing the AI to think beyond, in a sense, these kind of technical restraints. We can be a tool that all of this future development of the metaverse, where people are building digital worlds and new characters and having completely new experiences, we can be the foundation for that. We can be the most innovative, most creative tool on which people build these digital worlds. And I think that's amazing in the digital metaverse, and it's also amazing if and when it spills into the physical world as well.
I'm happy that we see the full video now. It's really exciting to see how those architecture models are created. So now I welcome Remy again here. And Remy, cool project. Maybe you just start and ask the team your question.
So first of all, thank you very much for this excellent submission and presentation. Obviously, generating virtual cities and landscapes is a very important piece of our craft. So here is my question. I would like to know how you would compare Malaxar to other procedural solutions like Houdini or specialized middlewares like City Engine in terms of customization. For example, what I mean, can you support fantastic cityscapes with exotic topologies like overhangs, suspended gardens, or just arches connecting buildings together? Thank you.
Yeah, thank you. It's a great question. I think it's also probably why we are most excited about this technological approach is if we compare ourselves against someone like Houdini or City Engine, they're both great examples that tend to rely on procedural software. So I know you're very familiar with procedural software, but as an oversimplification for everyone here, something that would be more akin to conditional statements. What happens is to get to an urban scale design, you end up with a lot of repetition because you have so many if-then statements. And again, this is oversimplified, but you get something that's more akin to copies of copies. So we've spoken with a lot of game developers, and they've said that they tend to shy away from things like Houdini or City Engine because it tends to lead to repetition in their urban scale designs. Whereas in their nature assets, like in a forest, that tends to work very well. So our approach on a technology level is fundamentally different, and that has a few implications. One is because of semantic information, our designs can be changed, updated quickly, altered for simulation data in basically no time at all, or searched and queried, and that has a huge implication in changing the style of the city. So if you would use a procedural software, it would be very difficult, for example, to go from a Gothic style city and to a futuristic style city because the parameters involved are so fundamentally different. But in our approach, that's not difficult. That's actually the solution space, the potential solution space of the underlying technology approach, because it's based on extracting style and reference, style from reference images, makes that a kind of fundamentally change. And I think that's where it's really exciting because we're able to generate these worlds that can be really diverse, much more diverse, I would argue, in terms of their architectural 3D form, in terms of the individual spaces inside the buildings, and in terms of the facades and the elements there that exist compared to something like Houdini or City Engine.
Thank you. So from what you're saying, you can actually learn architectural style from images. Is that correct?
That's correct. We use a few different things that we feed into our AI engine. So we feed in everything from architectural drawings like plans, sections, and elevations. We feed in 3D models, and we feed in images. But the user, actually, the generated content is based off of two things. It's the reference images that the user would provide, so something like the mood board from your game, and your gameplay constraints. So this could be something as simple, for example, as lines of sight, if that was a key gameplay criteria for you. And then from these two starting points, the AI generates these catalogs and cities of models which you can look through to then further iterate upon and refine.
Thank you. I think I better understand now, like the huge potential of your technology. Thank you.
I think I just want to say that one thing that I really liked when you spoke earlier is that this need for the human, and I think that's kind of the basis here, is we're trying to augment their intuition. So we're not trying to replace them, but we're really trying to make their creativity more efficient. So thank you very much for your question.
Yeah, thank you very much to Remy, and thank you to the team. And yeah, we're moving on. And those were the 7 teams. And I want to thank all of those teams. Now we've gotten all our information. And now you at home get to cast your vote for the Audience Award. You will see a link down below that will lead you to the voting page. You can copy this link down here, or you just scan the QR code with your phone. Pick the team you liked most and pick fast, because you have only 5 minutes to make your choice. To remind you of how tough that choice is, we have prepared an overview of all 7 finalists. So here we go.
The idea came to me that these days, the motion capture doesn't need any markers. Why don't we do the same thing on the smartphones? To give an example of a home workout assistant using our API.
I think in short, our model is capable of predicting player churn and pass rates in games without actually involving any human players.
And we thought it would be very cool if we can not only generate images in 2D, but if we can make these images 3D controllable. But the important part is that in our project, we want to learn this only from raw 2D images.
Architecture design is a manual, inefficient, and inflexible process. And this is a problem when designing one house, but it's a huge problem when you design an entire city level or world. And that's exactly what happens in video game design. So our startup is creating an AI engine to generate architecture models for the video game industry.
When we play some kind of computer game, there is a close-up of a person. This is not as expected, the quality. And we want to fix that using the recent developments of the AI technology, and thereby make it look more realistic.
The idea of Kinetics is to create a platform to allow all the creators and in-game creators to animate their own avatars leveraging AI.
The idea of my project is human or generating human motion and synthesizing face expressions for the Unreal Engine.
That is not an easy choice. So many cool projects. And yeah, you have some time to vote now. And now we are going to look at something interesting too. And this is research and gaming. And it's about motion capturing. And we prepared a little bit video that will explain it a little bit better. So here is the video.
So computers are a long way from understanding us. And so a key goal of the Perceiving Systems Department is to train computers to see us, to see our behavior, to understand us. This all begins with data, which we capture here in our capture hall. This data is combined with new machine learning algorithms, in particular deep neural networks, to train computers to see us in images and video. And so from an image or a video, the computer can then extract the motion of the person, the shape of their body, and the contact with the environment, and maybe even their emotional state and what it is they're trying to achieve. And so it all begins here in the capture hall.
Welcome to our capture hall at the Max Planck Institute for Intelligent Systems in Tübingen, the heart of the Perceiving Systems Department. Researchers from all over the world work here on training computers to see and understand us. The first step is to capture the three-dimensional human body in motion. 66 high-resolution cameras capture the body from various viewpoints to allow the reconstruction of the 3D shape and motion. Such raw data is used to generate statistical body models or avatars. These are then used to train computers to understand human pose and motion in images and videos. fine details in our facial expressions and hand gestures are important when we communicate with each other or interact with the environment. The goal is to understand the natural appearance and the motion of the human face. Capturing hands in motion is a very challenging computer vision problem. The scan data we collect helps us understand better how we interact with the physical world. It is not enough to study the human body in isolation. We are constantly in contact with the environment, with objects, with other people. This is why we use capture technologies that allow interactions and more freedom in space. In our motion capture system, we can capture multiple people who move freely and interact with objects and with each other. The reconstruction of the motion of the bodies and the object can be seen here in real time. The data we collect enables us to teach computers how we look and how we move. Digitalizing the human body is of great importance. We see vision as the process of inferring the causes and motivations behind the images that we observe, the story behind the picture. And the most interesting stories involve people.
This looks so cool too. I'm a little bit jealous. When I'm doing my research, I'm only sitting at a desk and typing in at a PC. So this motion capture hall looks great. Michael Black is with us. Michael, we're running out of time, but I have a question because I think this might be a little bit difficult for you. How challenging is it to transfer the research results you get to applications in gaming? Maybe you can answer this.
Yeah, so at Max Planck, we're a basic research institute, and we don't have the resources to go all the way from the basic research through to applications that touch customers. And the path from a research paper to an actual product that is in use every day is huge, right? And this is why this is what startups do. Technology licensing in startups is the way we deal with that. So we try to spin off companies where people take their research ideas, build teams, and take it to market. And that takes years after the basic research to get that done.
Okay, so it's a little bit difficult, but yeah, we will see those results in the reality, in our reality, for example, in gaming, and this is so cool. I'm so sad because we're running out of time. I would like to ask you more questions, but one team, I think, will have the chance to visit you, so maybe they can ask you more questions. Well, now, I've just been informed that the voting from the Audience Award has been closed, and in just a few minutes we will find out who won. So let's take a quick look at the green room with all the contestants. Let's see if they are a little bit nervous maybe, because soon they will know what if they win or not. So maybe you can show me by thumb up or thumb down. How are you doing? Are you fine? I hope many. Okay, all are fine. That's good to know for me. And I want to make a quick round because this event is about gaming, and maybe everybody has a favorite game, I guess. Maybe we can make a quick round and everybody just say what is your favorite game. We go one after the other. I would say we just start with team number one and then go on. So
should I answer? Yeah.
Yes.
So my favorite game is, for example, the Cyberpunk, and I like also some simulation stuff like Satisfactory.
Okay, just move on with team number two.
Mine is Lineage 2, and actually today they just released the mobile version, so if you want to play.
Okay, team three. Where is team number three? I think it's NeuroCG.
Oh yeah, so my favorite game is NFS, so Need for Speed. But recently they are such demanding for the computers that I kind of stopped playing a couple of years back now.
Too much work to do. Now we have Team Malaxar.
A bit of an old one, but maybe Grand Theft Auto 5.
Okay. And Team Graf.
I think my favorite one is The Witcher.
Oh, great game too. And Team Zavita?
My all-time favorite is Age of Empires, and I also like the Dishonored.
Okay, so I hope I haven't forget a T, or I forget the playtesting team, team number 6. Maybe.
That's right. I think lately I would say Life is Strange, first part, my clear favorite.
I totally understand you. There are so many cool games. I like The Witcher. I like Life is Strange. Great to hear all those games. And well, I don't want to let you wait anymore. So let's get to the awards. And I have the first award here. We have 3 awards in total. The Audience Award that will be presented by Shinya Kasuga, the Scientific Award by Michael Sedelmeier, and the Main Award, which will be presented by Rémi Durencourt. And Shinya, your company, IT Farm, is sponsoring the Audience Award. What will the winner receive?
Okay, the winner will receive exclusive mentorship from IT Farm, such as fundraising advice, customer pitch brush-up, and business planning, etc.
Okay, so this is a cool prize, and I would say we should check out who won the Audience Award. And we have 3 teams, and let's see. Oh, it's a close call, but one team wins. And what is the name of this team? It's Team Kinetics. You won. Congratulations. You won the Audience Award. This one over here. Congratulations. So, you won a mentoring from IT Farm. What is the most important topic for you that you want to talk about with them?
I guess it will be fundraising. We will be starting our next round in January. So I think it's the main focus for now.
Okay, so fundraising. I wish you all the best with that and with your project. I'm pretty sure we will hear of it again. So now we move on to the next award, and this is the Scientific Award, and this one was sponsored by Cyber Valley and presented is it by Michael Sedelmeier. Michael, please tell us which team will take home this trophy.
Okay, drum roll. And the Oscar goes to Team Graf. Katja Schwarz et al., congratulations. We were very impressed by the great work that you did, the scientific quality and also the potential for industry in terms of the impact. There's also a NeurIPS paper that came out of that, and for those of you that don't know NeurIPS, it's one of the most important top-tier conferences, of course, in that area. The original prize was a trip to Cyber Valley, but as you're already located in the Cyber Valley, the organizers offered to think about a different prize for you. So congratulations.
Congratulations here. It's good to hear that you don't win a trip to the place you're already are. That's great. But you also will get this trophy. So congratulations to you. Maybe you can tell us what are the next steps you have planned?
Wow, that's super cool. I didn't expect this. Yeah, for the next steps, we're definitely working on making it even like Graph, making it more photorealistic and also making it faster and easier to train. So yeah, this is what we're working on next. Maybe also making it more, like even more control, making it even more controllable. So I think there's a lot of very interesting directions that we can explore.
Definitely, and like I said, to all the teams, so much potential. So congratulations, and now we get to the last award, the main award, and it is sponsored by Square Enix and presented by Rémi Durencourt. Rémi, it makes it's time to make someone really, really happy. So who did the jury pick?
Another drum roll. Someone in the audience, please. So the main award is going to go to James Ben and the Malaxar team on the procedural generation of cities.
Congratulations.
So overall, that's an excellent submission, very well balanced. You are proposing new ideas, it's very creative, and yet mature enough we can talk about usage to potentially production, integration into a workflow. So excellent submission. And the main award is going to be for 3 of your team members, including yourself, to come to Tokyo so we can discuss face-to-face an actual collaboration. So now I know it feels a little bit anticlimactic. A few days after Japan announced we're going to close borders because of COVID. But we're going to talk on Zoom, and as soon as the borders open, let's talk face to face.
That's brilliant. Thank you so much.
Yeah, cool prize. So congratulations. You will go to Square Enix, big game developer. On a scale from 1 to 10, how excited are you?
I think 11. It's really very exciting. So it's great for us, and very happy. Thank you.
What do you look forward most to in Japan?
I can't think about it now, but I think just to work with the guys and to see what a potential, kind of collaboration there could be is really, really exciting.
Do you have like a future vision for your project? Do you know how your future might look like?
Yeah, we work with a lot of game developers and pilot projects. So we have this future idea that, especially as the metaverse grows, we could really be a major platform on which people design their 3D worlds. So I think, and this is a good way to get started moving towards that vision. So,
is there a game that you would be really excited to see your technology in?
I think there's no one game that stands out, but it's more the idea that open world games and roguelike games can start to have really creative, diverse architecture, much more than they even presently do. And I think that's, very exciting.
Okay, so this sounds like a great future, and this is a really cool prize, and I think you will remember this trip for the rest of your life. So this was the AI GameDev contest, and I have to say it was very exciting to get all those insights, and I'm really looking forward to see what those teams will do in the future. I'm pretty sure we will hear of them again. So thank you to all the contestants, thank you to the jury, and to all the people who made this competition possible, and thank you to all the viewers for your interest. And now it's time to say goodbye.